Okay, so my name is Emerson, and my term project was on finding similarity between images based on their style. The source of inspiration for this project was wanting to find similar style images to use as wallpapers. This could mean anything from the composition of the image, the general colors in them, the type of things that are in the image. You get the idea. Luckily, I already have the images sorted out by artist, so my idea is that I can use this to my advantage for detecting which images are similar in style and which images are not. The goal here would be to take in an image and create an embedding that contains information about its style. The different values could represent different aspects of a style and how much of each of those is in the picture. A convolutional neural network is the clear choice here. Outputting a simple embedding of around 10 values seems like an ideal way to achieve this. The typical CNN shape should do just fine. I decided to use triplet loss for training. 2 images would be from the same artist and 1 from a different artist. 2 pictures with similar embeddings should then suggest a similar style, and taking the difference between the embeddings should give a value as to how similar they are. For the model, I decided to use a pre-trained ResNet 18, as it should already be good at finding general image features at both large and small scales. It would also make it more likely to work on the smaller dataset that I have. I changed the fully connected layer at the end to output an embedding instead. Starting off, the network got to about 65% accuracy and trained pretty quick because of the pre-trained starting point. However, the results were mostly sorted by what objects were in the picture. This was to be expected though, as ResNet was trained to classify objects, and I was mostly just changing the end part of the network. To discourage this and identify more of the artistic style, I changed the network to a shape I call the waterfall shape. I would have it pull from different depths in the network and feed it into different parts of the embedding. This should pull out information at different detail levels and not just use the high-level information of what objects were in the scene. The embedding would then contain information about the style at different detail levels. Under the assumption that the style is the same across the image, I completely averaged each channel before going into the fully connected layers. I also left these layers disconnected from each other so they would influence their own separate values in the embedding. This would force it to use some information from each depth. Using this model decreased the accuracy of the network to 65%. This was not what I was hoping for. Looking at the embeddings though, it was clear that mostly the high-level details were contributing to the embedding, so it was effectively now an embedding of a smaller size. This would explain the accuracy decrease. Disabling this part of the embedding would immediately bring the accuracy back down to the starting point, so it was clear that it was just using this part of it. If I disabled the output from the last layer and then trained it, it would take longer to train but eventually made it to a higher accuracy of 75%. Now we're headed in the right direction. It was clear that there was now more contribution from the lower levels. Also, along the way, I made a tool for visualizing the features as well as the weights within the network. This was helpful for understanding more about what was going on. Here you can see the weights, and here are the features. So to try to fix the problem of the skewed use of the embedding, I applied batch norm to the embedding, mistakenly thinking it was layer norm, but this ended up making it train much faster and got to a higher accuracy of close to 80%. The embeddings were also starting to use more of the lower level details, and they were more unique for each picture as well. I then applied the layer norm I was thinking as well, and while the accuracy didn't change, this evened out the embedding a little further and was giving the best results so far, in my opinion. Here are some examples of the results. These are groups of images that had similar embeddings. While around 80% doesn't seem like a very high accuracy, the results that it was giving are a fairly similar style. It would make sense that correctly categorizing by artist would be a hard task anyways. Artists can also change their style over time, which would make the dataset inconsistent for training, making it even harder to guess correctly. Overall, I'm quite satisfied with the results, and this will definitely be a useful tool in the future. Anyways, that wraps up what I have for my project. Thank you.